Hello dear students, welcome back again to Chinmoy's biology channel. So we are back with the new episode of states of matter, that is the second part of matter in our surroundings. Hope you already have gone through the previous part where I have taught you about the physical nature of matter, characteristic of particles of matter. So let's get started without further delay, that is states of matter in today's episode. So, what are the learning objectives of today's episode? We are going to discuss in details about the states of matter, about solid, liquid, and gas, their properties, with a huge number of activities and examples. So, without delaying, we want to get into the topic. Let's start with the topic of states of matter. So today we are going to start about the states of matter. So we all know that there are three states of matter: the solid state, the liquid state, and the gaseous state. And I hope you all have gone through the previous episodes where I have already discussed about the characteristics and all. So please go through that. If you have not gone through that, I would share the link in the description box so that you can go through that previous episode and then start with today's one. So now we can see the different states of matter which are existing around us in three different states, that is solid, liquid, and gas. And these states of matter, they arise due to variation in the characteristic of particles of matter. Now let us study about the properties of these states. So first we are taking the solid state. So the first activity, let us do the first activity. So we are going to collect some articles like pen, book, needle, and a piece of wooden stick. Now sketch the shape of the above articles in your notebook by moving a pencil around them. So you are taking those book, needle, or a wooden stick, and you are taking the sketch, placing them on your notebook. So do all these things are having a definite shape? Yes, obviously they are having a definite shape with distinct boundaries and a fixed volume. Now what happens if they are hammered, pulled, or dropped? So what is happening? So are these capable of diffusing into each other? And try compressing them by applying force. So what you are seeing, are you able to compress them? So you have to jot down a few observations in this activity. So what are the observations? So we can observe here that all these are having definite shape, they are having distinct boundaries, and they are having fixed volumes, right? So we know that a book, a needle, a piece of wooden stick, a pen, they are having a fixed volume, that is, they have negligible compressibility. So how much ever you compress them, they are having negligible compressibility. Solids have a tendency to maintain their shape when subjected to the outside force, and solids may break under too much force, but it is difficult to change their shape as they are very rigid. So consider the following now. Now, what about a rubber band? It can change its shape on stretching. Is it a solid? What about sugar and salt? When they are kept in different jars, these take the shape of the jars. Are they solid? What about the sponge? Is it a solid and yet we are able to compress it, and why? So these are very important. You should know that about a rubber band, why it is changing its shape on stretching, and when we are leaving or releasing the force, again it is coming back to its original shape. Now what about sugar and salt? So let us go to the answers. Now first, all the above are solids. A rubber band changes its shape under the force and regains the same shape when the force is removed. So if excessive force is applied, it will break. Okay, now this is very important. Now the next one is the shape of each individual sugar or salt crystal remains fixed, whether we are taking it in our hand or putting it in a plate or in a jar. So the shape of individual crystal of salt and sugar is same. So as they are very fine particles, when we pour them in any shape of a jar, they will take the shape of a jar, but they are not liquid or gas, they are all solid. Now what happens to the sponge? A sponge has minute holes in which air is trapped when we press it, and the air is expelled out when we are able to compress it. Now this is all about the solid state. So from this we can find out the properties of solid also, that is, they are less compressible, they are having a definite shape, they are having a fixed volume, they are having distinct boundaries. Now we will move on to the liquid state. Okay. Now, first activity here, what they have given, that collect the following, that is water, cooking oil, milk, juice and cold drinks. So containers of different shapes, put a 50 ml mark on each of these containers using a measuring cylinder from the laboratory. So what will happen if these liquids are split on the floor? So measure 50 ml of any liquid and transfer it into different containers one by one. So what we are doing, we are measuring 50 ml of a liquid. We have taken the 50 ml container from the laboratory and we are now measuring any type of liquid, and they are being poured into different containers. So does the volume remain the same? Yes, obviously the volume is 50 ml. But the shape of the liquid is not same. Does the shape remain the same? No, because all the different containers are having different shapes. So they are taking the shape of each and every container. So when you pour the liquid in one of the container into the other, does it flow easily? Yes, obviously there is no problem of flowing of liquid from one container to another. So what we observe in this? So our observation is that liquids have no fixed shape, but they have always a fixed volume. They take up the shape of the container in which they are kept. Now liquids flow and change shape, and so they are not rigid but can be called a fluid. So liquids, they can be called fluid. Now refer activities 1.4 and 1.5 where we saw solids and liquids can diffuse into liquids. Now the gases from the atmosphere diffuse and dissolve in water. These gases, especially oxygen and carbon dioxide, are essential for survival of aquatic animals and plants. Now if this oxygen didn't diffuse in water, what would have happened? So what about the survival of the aquatic animals and plants? So as they are dissolving in water, the gases from the atmosphere, they are diffusing in water, so only the aquatic plants and animals are surviving. Is it clear to all of you? Okay, so if you are having any doubts, please ask me in the comment box. Now, all living creatures need to breathe for survival. The aquatic animals can breathe underwater due to the presence of dissolved oxygen in water. We may conclude that solid, liquids and gases can diffuse into these liquids. So, the rate of diffusion of liquids is higher than that of solids. So in solids, the rate of diffusion is lower, and this is due to the fact that liquid state, the particles move very much freely and have greater space in between them. So the main property here is that the liquid, the particles move freely and they have intermolecular space is much more than that of solids, other as compared to the particles of the solid state. Is it clear? Now, in solid state, the particles are not moving such freely. In liquid, they are moving freely. The intermolecular space between each of the particles is more, great space is there as compared to other particles in solid state. Now, when we move on to gaseous stage, we will see that in gaseous particles or in gaseous state, the particles move even faster and more freely. So, let us move on to the gaseous state. Now, gaseous state, we will now discuss about the gaseous state. So, let us see. Now, however, we have observed a balloon seller filling a large number of balloons from a single cylinder of gas. So, a huge number of balloons can be filled from a single cylinder of gas. So, from that only we can assume that gas can be compressed more. So, it is having a compressibility property. So, inquire him about how many balloons he is able to fill from one cylinder. Ask him. So, whenever you are going outside a park or something, you can just ask the balloon seller that from one cylinder approximately how many balloon can he fill. So let us take an example, an activity. So we are taking 300 ml syringes and closing their nozzles by rubber cork. As shown in the figure, we are closing their nozzle by, here you see that we are closing their nozzle by rubber cork and removing the pistons from all the syringes and leaving one syringe untouched, filled with water in the second and the pieces of chalk in the third. Now we are inserting the first, we are keeping the it is untouched, second we are filling it with the water, and third we are filling it with chalk dust, and another one we are keeping it untouched, that is it is being filled with air. Okay, so insert the pistons back into the syringes, and you may apply some Vaseline on the pistons before inserting them into the syringes. For the smooth movement of the piston, you can apply Vaseline on the surface of the piston and you can just press them. So now try to compress the content by pushing the piston in the syringe. So what you will see, so what you will observe, and in which case the piston is easily pushed in. So the piston will be easily pushed in case of gas. And what do you infer from the observation? So let us see what is the inference. You just think. So we have observed that the gases are highly compressible. The gases are highly compressible as compared to solids and liquids. The liquefied petroleum gas or LPG, which we are daily using in our home cooking, or oxygen supplied to the hospitals in cylinders, are all compressed gas. Now compressed gas is a natural gas and is used as fuel for those vehicles. Now, due to high compressibility and large volumes of a gas can be compressed into small cylinders, and we can say that they can be transported easily. So, we have come to know that what is being cooked in the kitchen without even entering there, by the smell of it reaches through our nostrils. How? Because the particles of the food, they mix with the particles of the air from the kitchen and reach us even we are far away. So if suppose your mother is cooking a delicious meal, you can just smell from your room that a delicious food is being cooked, and you can smell that from any part of the house in seconds, and compare this with the rate of diffusion of solids and liquids. Now, due to high speed of particles and large space in between them, gases show the property of diffusing very fast. So diffusing in gas is very fast than liquids also. So diffusion of gas is at the fastest rate. So in the gaseous stage, the particles move about randomly at high speed. Due to this random movement, the particles hit each other and also the walls of the container, and the pressure exerted by the gas is because of the force exerted by the gas particles as per unit area of the container. So the gas is moving so freely that it is hitting the walls, it is hitting each other particles, and a great pressure is exerted by the gas because of the force exerted by gas particles per unit area on the walls of the container. So thus we can say that the diffusion rate of gas is the highest. So liquid least is the solid, then comes the liquid, and then comes the gas. Is it clear? Now here are several questions. You can just take these questions and answer them. Here just if you are having any doubts, please try to answer these questions on your own. Make your own answer copy and try to answer. If you are having doubts, you just ask me, I'll answer it. Now the mass per unit volume of a substance is called its density. Okay, we know that. So density is mass per unit volume. So arrange the following in the order of their increasing density. So air, exhaust from the chimneys, honey, water, chalk, cotton, and iron. So tabulate the different characteristics of the states of matter. Very good question. Comment upon the following: the rigidity, the compressibility, fluidity, filling a gas container, shape, kinetic energy, and density. Okay, so give reasons. A gas fills completely a vessel in which it is kept. So why does a gas fill the container completely where it is kept? We have just now spoken about that. A gas exerts pressure on the walls of the container. Why? Give reason. A wooden table should be called a solid. Why? We can easily move our hand in air, but to do the same through a solid block of wood, we need a karate expert. Why? So these give reasons. You can write. So just now we have dealt with the properties. Try to write on your own. If you are not getting, ask me, then I'll be discussing in the next class. Now liquids generally have lower density as compared to solids, but you must have observed that ice floats on water. Find out why. Why does ice float on water? So liquids generally have lower density as compared to solids, but you must have observed that ice is floating on water. Why? So that we will discuss. So this is a very important question, that have you observed that ice floats on water, and find out why. So this question we will be discussing in the next video in details. So it is having two parts, and I'll be discussing in full in two parts only, that why ice floats on water and why the density of ice is less than that of water, and so why it floats on water. So in details with all the principles I'll teach you in the next episode. So for that you need to subscribe to my channel. You need to stay tuned to know what more I I'll be teaching in the next episode. And as I'm teaching as per your curriculum, you should subscribe, share it with your friends so that you can get the updates of the videos, whatever I'm posting. Okay, so now let us move to the next topic, that is, can matter change its state? So we all know as per our observation that matter is having three states: solid as ice, liquid as water, and gas as water vapor. So what happens inside the matter during this change? What is the happening? So what happens to the particles of matter during the change of states? So how does this change take place? And we need answers to this question, isn't it? So we need to answer the question. So start heating a beaker on a low flame. You can see here the diagram. You have started heating a beaker. You have taken a thermometer which is fixed here. We have taken a glass stirrer. We have taken water here and a Bunsen burner, and we have fixed all this with an iron stand. So let us see what we are doing in the procedure of the experiment. So we have started heating the beaker on low flame. We are noting the temperature when the ice starts melting. We are noting the temperature when all the ice is converted into water. We are recording our observations for the conversion of solid to liquid state, and now putting a glass rod in the beaker and heating while stirring till the water starts boiling. Okay. Now we are observing it carefully. We are taking all the readings of the thermometer till most of the water has vaporized. Now record your observations for conversion of water in the liquid state to the gaseous state. Now, on increasing the temperature of the solids, the kinetic energy of the particle increases. Now, due to the increase of kinetic energy, when we are heating the solution, the kinetic energy is increasing. So, the particles, they start what? They start vibrating with a greater speed, and the energy supplied by the heat overcomes the forces of attraction between the particles, and the particles leave their fixed positions. They also start moving. So as the kinetic energy has increased a lot, the particles started moving with greater speed. The energy supplied by the heat, it is being overcome by overcomes the forces of attraction between the particles. So it is exceeding that, and a stage is reached when the solid melts and is converted into a liquid. So the minimum temperature at which the solid melts to become a liquid at the atmosphere pressure, so it is under a normal atmospheric pressure, and where the liquid starts melting, the solid starts melting to liquid, is called its melting point. So the melting point of a solid is a indication of the strength of the force of attraction between the particles. So what is melting point? The melting point of a solid is indicating that the strength of the force of attraction between the particles. Is it clear? So what is the melting point of ice? The melting point of ice is 273.15 degree Kelvin. And the process of melting, that is the change of solid to liquid state, is also known as fusion. Okay, so conversion of solid to liquid state is also known as fusion. So when a solid melts, the temperature remains the same. So where does the heat of energy go? Okay, the solid is melting to the liquid, and the temperature remains the same. So where the heat energy is going? So we must have observed in the experiment that the temperature of the system is not at all changing. As we have placed the thermometer there, we can see that the melting point is reached till all the ice melts. This happens even when we continue to heat the beaker. So the temperature, the thermometer temperature is the same. So where does the heat go? So that is, we continue to supply heat, and this heat get used in the changing of the state by overcoming the forces of attraction between the particles. So what is this heat called? This heat energy absorbed by the ice without showing any rise in temperature is considered as the latent heat. So this latent heat, in the next slide we will be studying in details what is latent heat. So what is latent heat? It is the heat energy being absorbed by ice without showing any rise in temperature, and it is considered that it gets hidden into the contents of the beaker and is known as latent heat. So what does the term latent mean? This term latent, it means hidden. So this term latent, it means hidden. So latent heat is the hidden heat. So the amount of heat energy which is required to change 1 kg of solid into liquid at the atmospheric temperature at its melting point is known as latent heat of fusion. We have already told that this conversion of solid to liquid is also called the fusion. Okay, so this conversion of solid to liquid, the latent heat of fusion, we can also say that it is called the latent heat of fusion. Okay, so the particles of water, they at 0 degree centigrade, 273 degree Kelvin, they have more energy as compared to particles of ice at the same temperature. So we can say that when we supply heat energy to water particles, they start moving very fast. We have already told that the kinetic energy of that water increases, and at a certain temperature, a point is reached when particles have enough energy to break free from the forces of attraction of each other. So they are being heated, they are started moving fast, and they are having an energy to break free from the forces of attraction. And this temperature, the liquid starts changing into gas. So they are breaking free from the forces of attraction. So no attraction between each other particle is there. They are breaking free from the forces of the attraction. No attraction is there between each particle, and they are being converted into gas. The temperature at which the liquid starts boiling at the atmospheric pressure is known as the boiling point. So what is boiling point? Under the atmospheric pressure, when the liquid starts boiling, is the boiling point. So boiling is a bulk phenomena, and particles from the bulk of the liquid gain enough energy to change into vapor state. So they are gaining enough energy from the liquid to energy to change them into a vapor state. So for water, the temperature is 373 Kelvin, or 100 degrees is equal to 100 degrees centigrade. That is the boiling point of water is equal to 273 degree Kelvin plus 100 is equal to 373 degree Kelvin. Okay, so now we are going to discuss about what is latent heat in the next part. Now, I've told you that I'll be discussing you about what is latent heat. So this is very important. So please learn it properly. So what is latent heat? Latent heat is defined as the heat or the energy that is absorbed or released during the phase of change of a substance. Suppose a solid is being converted to liquid, or a liquid is being converted to gas. So the heat or the energy that is absorbed or released during this phase. So latent, we have already told that the term latent means it is hidden form. It is in hidden form. So this form is called the hidden heat. So it could either be in the form of a gas to a liquid, or a liquid to a solid, or vice versa. Okay, the latent heat is related to a heat property that is called enthalpy. So in higher classes, you will be dealing with enthalpy and all. Now, no need. Just you understand that it is the heat or the energy that is absorbed or released during the phase change, okay, of a substance. So however, an important point that we should consider regarding the latent heat is the temperature of the substance remains constant, and as far as the mechanism is concerned, the latent heat is the work that is needed to overcome the attractive forces. So it is the work done which is needed to overcome all the attractive forces and hold the molecules and the atoms together in a substance. So it is helping to overcome all the attractive forces that holds the molecule and atoms together, and they are overcoming the forces, and they are becoming free, and they are able to move from one state to another. Okay, so let us take an example and discuss. So suppose a solid is changing to a liquid. It needs to absorb energy to push the molecules into a wider and more fluid volume. Similarly, when a substance changes from a gas phase to a liquid phase, its density levels also need to go from a lower to a higher level, and wherein the substance that needs to release or lose energy so that the molecules come together. In essence, we can say that this energy is required by a substance to either freeze, melt, or boil. So whatever this change of phase or change of state, the energy what is required by a substance either to freeze or to boil or to melt is called the latent heat. So today we are ending the episode here only. So in the next episode, there are many things more to study in this states of matter, like sublimation, effect of change of pressure, evaporation, factors affecting evaporation, and how evaporation is causing cooling. So you need to subscribe to my channel to know more regarding my lesson, and you need to get the updates of all this lesson. So stay tuned, stay updated, and for getting the updates, please subscribe. Don't forget to share it with your friends. So seeing you soon. We will be back with this lesson sublimation and evaporation. Thank you.